over the x or the y-axis. Now I'm going to ask you to reflect over a horizontal or a vertical line that are not actually on the x and y axis. And the equation y equals 1 is the equation for a horizontal line. And here's where that horizontal line comes from. The y-axis is here, right? So this is going to have something to do with the y-axis because it says y equals 1. What this represents is a horizontal line that just goes straight through the 1 on the y-axis. So anytime you see an equation that just says y equals a number, basically what that means is it's going to be the equation of a horizontal line. Now, I am not talking about y equals mx plus b. Okay, that's, did you all do that a little bit last year at all? No. Oh, yay, okay. Yay, I get to teach you that. Okay, so this is just a plain old y equals. And where the equation comes from is it basically means that every y coordinate is a 1. So if you like imagine these little coordinates going along that vertical line, they're all going to be sitting where y equals 1. So that is why y equals any number is just going to be a horizontal line that goes through whatever number that is on the y-axis. I'll bet you guys can take a pretty good educated guess about what the x equals -2 might be. Instead of it being a horizontal line that goes through the y-axis, what do you think an x equals equation might be? Going through the x-axis, correct. So we would go over to the x-axis at x equals -2, which would be here. And instead of it being a horizontal line, this one is going to be a vertical line. I'm going to do a real crap job. Let me try this right here. I'm not going to do a very good job. Oh, that's decent. I wish there were a ruler on this thing so bad. Okay, so if it's a horizontal line, it'll start with a y equals, because a line that literally goes through the y-axis at whatever point they give you. If it's an x equals, it will be a line that goes through the x-axis at whatever number they give you. So that's the really only new piece of information. All you are doing now that you know how to do a horizontal and a vertical line is you're just going to reflect like you did yesterday. It's just going to be over, a horizontal or vertical line that's not the axis. So if I zoom in here on number 1, for example, I'm going to change my ink color. Since V is 2 units above the mirror line of reflection, V prime will be 2 units below that line of reflection. A common mistake that I see a lot of people make on problems like this is they look at the axis and where it was in regard to the axis instead of where it was in regard to the line of reflection, because that axis is what kind of sticks out to you, right? So I see that go wrong a lot, that people look at the axis instead of looking at the line of symmetry or the line of reflection, which we have. So the line of reflection, the V is 2 units above, which means that for your image after, it will be 2 units below. And make sure that you add that little exclamation, apostrophe kind of thing, your prime notation. What about the T? What do I do with that T? It doesn't go anywhere. If it's sitting on the line of reflection, it stays put. So you can literally just kind of write like a T prime over the top of that T. If it's sitting on the line of reflection, it doesn't actually move. There's nothing for it to reflect over. And then last but not least, if U is 1, 2, 3, 4 units above the line of reflection, it's now going to be 1, 2, 3, 4 units below the line of reflection. So 1, 2, 3, it'll be right here. Do a better job than I'm doing with rulers and such. Please, bless you. And the issue with this one is that there is no cutesy expression that you can use to make sure the coordinates are right, because the coordinates are going to vary depending on whether, like what the line of reflection is. So there's no keep this coordinate and change the sign of that one. It really depends on whether you're doing it over like a vertical line or horizontal line and like where it is. So on you've got the same type of assignment. Oh, I'm just gonna actually do number 2 because 2 is a little silly and goofy because it's reflected on top of itself. Anybody not okay if I scroll over to number 2? We're okay? All right, cool beans. Okay, so this one is a little goofy because it flips on top of itself, but you do run into this a lot, so it's important to make sure you know how to do it. So again, my axis of reflection is x equals -2 because it is a vertical line that goes through the x at 2. And I'm just going to count. So from my line of reflection over to point J, that is 3 units to the right. So if I'm going to reflect unit J, or point J, over to the other side of that line, it needs to be, instead of being 3 units to the right, it now needs to be 3 units to the left. Add your prime notation, please. Make sure you don't you do all the hard work when you have a quiz coming up fairly soon. And it won't be tomorrow or anything because we still got to do rotations. But don't do all the hard work and then not get a full credit because you forgot your prime notation. Okay, the G is 2 units to the left of the reflection line, which means that your G prime will be 2 units to the right of your reflection line. H, you can see where we're going with this, is 3 units to the left of your reflection line, which means it will be 3 units to the right after it is reflected. Did I get that in the right place? 1, 2, 3, 1, 2, yeah, okay. And last but not least, I was 1 space to the right, which means that it is now going to be 1 space to the left for I prime. Make sure you connect your dots. Oh. Oh, no, don't go anywhere. And use your prime notation. Alrighty, so you guys have a class kick that helps you to practice this, and it does the same thing as yesterday where you'll have a little answer box so that you can check one of your coordinates to make sure that it's in the right place. In addition,